I finished the last video by saying that strings are immutable, whereas lists are mutable. When an object is described as immutable, that means it can't be changed. The following immutable types are built into Python: int, float, bool, which is true or false, subclass of int; string, or str, which is a string; tuple, frozen set, and bytes. So it should be obvious that an int like 5 can't be changed. 5 is always 5. You can add another value to it. For example, we can add 1 to 5 and we get a new number 6. However, we can't change 5. The same is true of floats. 3.14159 will always be 3.14159. Once again, we can perform arithmetic with a float and get a new float value, but we can't change the value of 3.14159. So stay with me on this because there might be an obvious question that you're asking. I'll explain that next, but at the moment trust me that these values are immutable. Bool values are also immutable, and so are strings. The question you're asking is probably becoming disbelief now. So let's type in some code now that proves this. So I'm going to create a new Python file here called Immutable for these examples. Right, so let's start by typing result equals true, true with a capital T. Another underscore result is equal to result. Print on the next line, left parentheses ID, left parentheses result, then two right parentheses. And on line 4, print left parentheses ID, left parentheses, another underscore result, and we've got our two right parentheses to end the line. All right, so here we've got two variables, result and another underscore result. They're both bound to the value true. On lines 3 and 4, I've printed out the ID of those variables. Now it's worth checking the documentation for the ID function, so let's briefly do that. So as you can see there, ID returns the identity of an object. Now the documentation doesn't state that it should be the object's address, just that it must be guaranteed to be unique and constant for this object during its lifetime. The CPython implementation does return the object's memory address, but not all Pythons will do that. The ID for an object may be different each time you run the program, but while your program's running, the object will have the same ID. Of course, if Python has to destroy the object and recreate it, then its ID will also change. So that gives us a good way to tell if an object is changed or if Python has to create a new object. So let's go back to our code. Let's run it. And we can see here that both variables have the same ID. They're both bound to the same value, true, so that makes sense that it should have the same ID. Remember that we're printing the ID of true here. The variables result and another underscore result are just names that we've bound to that value. Alright, so if bool values could be changed, then changing the value should mean that the ID doesn't change. So let's see if that's the case. So I'm going to add some new code down here. Line 6 result equals false with a capital F. Then we're going to print left parentheses ID, left parentheses result, and the two right parentheses to end the line. Let's run that code. And you can see here we've got a different ID for result with the code that we've just added. Because bools are immutable, we weren't able to change the value of true. What Python's done instead is rebound result to a new value, false. When we were looking at the slides, when I said that bools were immutable, you may have been thinking, but hang on, I can assign a new value to a Boolean variable. Now that would be true in other languages. In C or Java, for example, you can assign new values to Boolean variables. In Python, though, that's not the case. Instead, we've attached the name result to a new value. So let's comment out all that code and use another example here. I'm going to type result equals double quotes correct with a capital C, and that's in double quotes as I mentioned. And in line 10, I'm going to type another underscore result is equal to result. And I probably could have pasted those lines before I commented out, but I'll just type it again. Print and left parentheses ID, left parentheses result. And the same thing this time for another underscore result. So we're printing the ID for both variables, again, as we did earlier. All right, so let's run the program. And you can see here that the variables, again, have the same ID. All right, so moving on, let's attempt to mutate result. Now we can use augmented assignment to concatenate more characters to the end. Let's have a go at doing that. Result plus equals double quotes ish. We'll print the ID again. So if we could mutate the string, then the value that result is bound to would change. The ID should remain the same if that happened. Let's run the program and see what happens. And it's not. As you can see, that result now has a different ID. Now, just in case you're not convinced, I'm going to print the ID for another underscore result as well. So let's do that. I'll just take a copy of that from line 12 and paste it in. Run that. So notice that the ID of result has changed, but another underscore result still has the same ID that it had to start with. Because strings are immutable, Python couldn't change the string correct. What it did instead was create a new string and bind the name result to this new string. Now don't worry if you're still a bit confused about this. It will make sense once you've seen the same thing with a mutable object. And we'll look at doing that in the next video.